Hi, guys. Okay, so in chapter 8, the last of the homework questions are 53, 55, and 57. So in this video, we are going to cover those. And let's look at those, 53, 55, and 57. So 53 here. Okay, so these relate to the reaction stoichiometry. So here we are given magnesium. Magnesium is reacting with HCl to give you magnesium chloride and hydrogen. Okay, so we need to find how many grams of magnesium is needed to react, to produce a certain amount of hydrogen. And the amount of hydrogen is, the volume is 5 liters. The pressure is 735 millimeters of mercury, the temperature in degrees Celsius. So this is a very important question, and I'm going to just put it here. This type of questions are going to be on the test. Okay, so let's do this. This is the reaction stoichiometry. All right, so here, first of all, there are a few things. First of all, in the reaction stoichiometry, so the relationship we are looking at is the hydrogen and magnesium. And yes, make sure that the equation is balanced. So we need to put 2 here. So always balance. Now, we are looking only at the relationship of magnesium and hydrogen. So the volume of hydrogen is given in liters, which is good. The pressure is millimeters of mercury, which is good, but that also tells us that the value of R is going to be different. The value of R is 62.4 millimeters of mercury times L over moles per K. Okay, now, how do you know about this? This is either on the test, sometimes it's given. If not, in my class, you will be having this information on the handout, on the table. So anytime the pressure is in millimeters of mercury, you use 62.4. If the pressure is in ATM, then you use the other value, which is 0.08206 liters atmosphere per mole K. Okay, so that's the value of R you take out. Next thing is the value of the temperature. So you need to convert that to Kelvin. So 18 plus 273, and that is 18 plus 273, and that gives you 291 K. Okay, so now at least all our units are like that relate to the formula of the ideal gas law. So temperature in Kelvin, pressure in millimeters of mercury, volume in liters, and the value of R we have brought here. So what are you going to do first? The strategy here is, first of all, find the moles of hydrogen. So find the moles of hydrogen from where? So the formula you will use is PV is equal to nRT. And from here, PV upon RT is equal to N. That's the moles of hydrogen. So that's the first step. What's the second step? The second step is the question is asking us to find the grams of magnesium. So you're going to take the moles of hydrogen and you're going to convert them to the moles of magnesium. So in this case, the ratio is 1 to 1. So if you know the moles of hydrogen, you can find the moles of magnesium. But ideally, it goes through the mole to mole ratio. So moles of magnesium on the top multiplying, right? And over, this is the moles of hydrogen. And that will give you the, so basically you multiply this. So that gives you the moles of hydrogen if the moles were different. Okay, now we have the moles of magnesium. So what are we going to do next? So here are the moles of magnesium. You're going to convert that to the grams of magnesium. And how would you do that? You're going to go through the molar mass. Okay, so molar mass is grams per mole. So molar mass of magnesium, and then you go from there. So let's set up this problem. So first of all, always write the equation. Second thing is make sure that it's balanced. Third thing is that change the units if they need to. So for example, if something is given on the side, if something is given in milliliters, let's say the volume, you convert it into liters. Okay, so milliliters into liters is using the using 1 liter. So using like 1 liter over 1000 milliliters. So sometimes, you know, that problem can be there. Next thing is sometimes they may like always convert the temperature into like Kelvin, and you know, and then these and the pressure and the R values should match as far as their pressure units are concerned. Okay, so all right, so let's do first find the value. So let's start doing this here. Let me do it in a different color, green. Okay, so first step is the value of the number of moles of hydrogen is equal to PV over RT. So here the pressure is 735 millimeters of mercury, okay, times the volume. Volume is 5.00 liters over the R. R value is 62.4 millimeters of mercury times L over moles, okay, times temperature 291, okay. Okay, so let's solve this problem. So 291 K times 62.4 is equal to 18. So this is 18,158.4. Okay, and the other one is 735 times 5. And that gives you, once more, 735 times 5. And that gives you 3,675. Okay, this is divide. So here, divide that by 18,158.4. And this is equal to 0.2023 moles. So let's just keep it here. So these are the moles of hydrogen. Okay, moles of hydrogen. So you find them like that. Next thing is, our next strategy is find the moles of magnesium. So the moles of magnesium, let's do it here, 0.20. So let's find it here. Moles of N, that's the moles of magnesium. So how would you do that? So we have the moles of hydrogen, 0.202 moles of hydrogen. I'm going to still set it up for you, times the mole to mole ratio. So how many moles of magnesium are reacting to produce how many moles of hydrogen? It's 1 to 1. So 1 mole of magnesium over 1 mole, actually it's not moles, it's mole, 1 mole of hydrogen. So this is 0.202 moles of magnesium. Okay, so here you see the moles of hydrogen and moles of hydrogen cancel out. All right, now comes the third part, which is you take the moles of magnesium and you convert that to grams of magnesium. All right, moles of magnesium to grams of magnesium. Moles of magnesium are 0.202 moles of magnesium times gram formula mass. 1 mole of magnesium, and the molar mass of magnesium is 24 grams of magnesium. Okay, so 0.202 times 24, and this gives you 4.85 grams. So 4.85 grams of magnesium. That is the mass of magnesium that is needed to produce about 5 liters of hydrogen gas, which equals to 0.202 moles. Okay, so that is the way you solve this, is a reaction stoichiometry problem, and they're going to be on the test. So reaction stoichiometry. So you need to master this, where we are applying the gas laws and in the reactions. Okay, so that's one piece. Now let me just double check this problem, 4.185, and this one was 53. So problem 53 4.185. I did part B, and it comes out to be 4.92 grams of magnesium, which is okay because I had rounded up and all that some places and so forth. So, you know, it's just, it's similar, it's close, okay? So that's the answer. Reactors are very important. Okay, all right. Next is you are given a scenario where you are given butane. It is going through a combustion reaction, and this is a problem 55, combustion reaction producing carbon dioxide and water. So all this is balanced. Now the question is, how many grams, or how many volume in liters of oxygen is needed to combust 55.2 grams of butane? And the pressure and the temperature is given to you. So what is the strategy here? The strategy, first of all, is that you are going to convert. So first is temperature, obviously, plus 273, convert that to Celsius. So that's kind of always a given. 25 plus 273, and that is 298 K. So you're going to use that. Next thing is the value of R. Which value of R are you going to use? Because the pressure is an ATM, so we are going to use 0.08206 liter atmosphere, excuse me, per mole K. All right, ATM is given, pressure. Volume, liters, we need to find. And the grams of the butane is given. So first thing is, find the moles, that is N of butane, C4H10. Okay, so find that. How would you do that? You're going to take the grams of C4H10, okay, and convert that to moles of C4H10. So what do you need here? You need the molar mass of C4H10. So if molar mass is 4 of carbons plus 10 of hydrogens. So 4 times 12 plus 10 times 1. And that gives you 12 fours are 48 plus 10. Plus 10. So this is 58 grams per mole. Okay, so this is one piece. So once you get the moles, the next is find the moles of oxygen. How? You take the moles of butane, and moles of, so let me put this here, find the moles of butane, which is N C4H10, right, times the mole-to-mole ratio, C4H10. And then from there, mole-to-mole ratio, and that gives you from mole-to-mole ratio. So let me just do this here. Using molar ratio, okay, between the two, oxygen and butane. Once you get the moles of oxygen, you are going to put this in the formula. PV is equal to nRT. Okay, now we need to find the volume. We got the moles of oxygen, so we can find the volume. Sorry, here. We found the moles. So here, PV is equal to nRT. So we know we got the moles of oxygen. We need to find the volume. So nRT over P, and that's going to give you the volume. Okay, so let's do this now. All right, so just let me just place out a few things here. Give me a minute. Okay, so let's do this here. We have find the moles. So number one, first step is the moles of butane, C4H10. So moles of butane is, you are given 55.2 grams of C4H10, right? And then what do? You times 1 mole of C4H10 over the molar mass of C4H10 is 58 grams of C4H10. Okay, so let's do this. So 55.2. Okay, 55.2 divided by 58. And that gives you 0. So the moles of C4H10 is equal to 0.951 moles. Okay, next is you are going to convert it into the moles of oxygen too. So N of O2, how do you do this? You take 0.951 moles of C4H10 times, all right, times here, times from the mole to mole ratio. Now you look at this here, we are looking at the relationship between the butane and oxygen only, and it's 2 to 13, the mole to mole ratio, okay, the molar ratio. So 2 to 13. So 2 moles of C4H10 and 13 moles of oxygen. 13 moles of oxygen. So 0.951 times 13, divide that by 2, and that gives you 6.18 moles of oxygen. Okay, so that's the value of oxygen moles. Next is the volume. So PV is equal to nRT, and from here we will do volume is equal to nRT over P. N is, so let's just plug in the rest of the numbers. So N is 6.18 moles of oxygen times R is 0.08206 liters atmosphere per mole K, times the temperature is 298 K over P. Pressure is 0.850 atm, 0.850 atm, and that is the value of the volume. So do this, 6.18 times 0.08206 times 298, and that is equal to 151.27. Divide that by 0.850. Divide by 0.850, and that gives you 177. So volume in that's going to be in liters. Volume is equal to 177.97. So 178 liters. Okay, so this is the 855. It's a 55, problem number 55, and that is 178 liters of oxygen, and that answer is also correct. Okay, all right, so that is the using the reaction stoichiometry to do the the problem. So this is again test questions, important questions. Now once again, the last question here is the 8.57. So you are given aluminum reacting with oxygen, giving you aluminum oxide. Balance the equation. You are given some mass of aluminum. You need to find a volume of oxygen at STP. Now here the question is saying at STP. So it's the same as you did earlier, but the only thing is because it's at STP, so I just wanted to do it. So this is the P. So whenever STP is given, that means you have to use the values for STP. So this is equal to 273 Kelvin. Okay, and pressure is 760 millimeters of mercury, or you can also take the pressure equal to 1 atm. So if you're going to use 1 atm, then the value of R is 0.08206 liters atmosphere per mole K. But if you're going to keep it at 760 millimeters of mercury, then in that case, you're going to convert it into in that case, you will use a different value of R. Okay, so same strategy, still write this down. So first thing is convert the grams of aluminum to moles of aluminum. So I'm going to just skip the other pieces. So moles of, this is the moles of aluminum. Let's put it here. This is equal to N aluminum. Next, you can convert the moles of aluminum to moles of oxygen. Once you get the moles of oxygen, you are going to plug it into the formula PV is equal to nRT, and through the rearrangement, we get V is equal to nRT over P. And that should, so this is a very basic thing. Now, let's start doing this. Problem number 1 here. So step number 1, 5.4 grams of aluminum is given. Convert that to mole. 1 mole of aluminum. Now from the periodic table, the mass of aluminum is, from the periodic table, the mass of aluminum given is 26.98. So it's okay to use it as 27 grams of aluminum. So this information, okay, so this gives you the moles. So 5.4 5.4, divide that by 27, and that is 0.20 moles of aluminum. Okay, next is the moles of aluminum. So 0.20 moles of aluminum times the, from here you have 3 moles of oxygen reacting with 4 moles of aluminum. And that gives you, so 0.2 times 3 divided by 4, and you get 0.15 moles of oxygen. Okay, now you have the moles of oxygen. Next, how can you find the volume? So plug it in the PV is equal to nRT, just like in the previous questions. And here, volume is equal to nRT over P. So here, 0.15 moles of oxygen times 0.08206 liters atmosphere per mole K times the temperature, and the temperature is 273 Kelvin. Always temperature has to be in Kelvin. Okay, over P, the pressure is 1 atm. Okay, 1 atm. So you see this, when you set this up, let's say the grams of aluminum cancel out, moles and moles of aluminum cancel out, and here moles and moles cancel out, K and K cancel out, atm and atm cancel out, and you're just left with unit of volume. So let's do this math here. So we have 0.15 times 0.08206 times 273, and that is equal to, divide by 1. So this is volume is equal to 3.36 liters and 3.4 liters. Okay, that's the volume. So that finishes the homework set from this chapter. Thank you for watching.